Welcome to the AgEmerge podcast, brought to you by Ag Solutions Network. Your farming challenges are unique, so your practices should be too. We're here to share emerging ideas, build connections, and provoke conversation.
Get ready to improve your soil, your crops, your livestock, and your family's livelihood. I'm your producer, Kim Chase.
And I'm your host, Monte. Thanks for joining us.
Thanks for joining us. Today we welcome Jerry Hatfield. Jerry is the retired director of the USDA-ARS National Laboratory for Agriculture and the Environment in Ames, Iowa, and his bio illustrates his passion and knowledge for helping growers improve their agronomic systems. Much of Jerry's focus has been on the evaluation of farming systems and their response to water and nitrogen interactions across soils, and remote sensing methods to quantify field variation. A platform for his research utilizes the genetics by environment by management concept as a framework to work with producers to demonstrate how they can increase their production efficiency, increase soil health, and develop resilience to weather and climate variation as the foundation for food security. Today, he and Monte dive into all those topics and many more. So let's get started.
Welcome, everyone, to this episode of the AgEmerge podcast. I am just honored to be joined by Dr. Jerry Hatfield today. I've known Jerry for a long time, and he's done just some amazing work in really moving the agricultural paradigm forward. So, Jerry, welcome. Glad you could be here.
Well, thanks, Monte, and it's my pleasure to be here as well. And it's just anything that we can do to get information out to producers, to get them to think and ask questions and do something, even increase their curiosity, has benefits to all of us.
Well, Jerry's been with the USDA-ARS for a long time. I remember director of the Soil Tilth Lab at Iowa State University, located at Iowa State University. And he's a retired now, but you don't do retirement well, do you?
No, I probably, as my wife says, I've probably failed at retirement. I spent a lot of time on Zoom calls and team meetings and things like that because I found that there's a lot of people that want information. And when I retired, people asked me what I was going to do, and I said, I'm going to take the knowledge I've built up over 45 years of research and figure out how to apply that to agriculture and everything. So, but the nice thing about retirement is that, I don't do early morning meetings and I don't do afternoon meetings. So, you kind of have limited space when you work around and everything. So you can always say, nope, I've got other things to do this afternoon. So.
Well, that's the way it should be. And it's pretty exciting. And I want you to dive into a little bit of your journey, Jerry, of just how you came along to have an understanding of all the interconnectedness, not only from a agricultural system, but now you're looking at even bigger things. So I won't steal the thunder there, but kind of just tell us your story and the journey that you've been on and just where that has led you to today.
Yeah, that can be the first hour of the broadcast, Monte, and in terms of looking at this. But if you look at this, I have a pretty interesting background. My bachelor's is in agronomy, but I think I'm the only agronomy major at K-State that actually squeaked by with the minimum number of credits in their major because I was taking math and physics courses. So that tells you that I'm a little bit strange from that standpoint in terms of looking at the different ways in which we could develop analytics. I got a master's out of the University of Kentucky looking at how plants responded to soybean germination processes, developed some pretty unique aspects there. But I got very interested when I was at Kentucky in saying there's more to this system in terms of the environmental impacts on agriculture. And so I was looking around for a PhD program and Iowa State offered me a teaching assistantship, and so I got my PhD at Iowa State in agricultural climatology with a minor in statistics. So I truly have gone in all sorts of different ways in all of this. But the bottom line of this, and really why I have an interest, is in looking at the system of agriculture. What is that connectivity between the soil and the plant and the atmosphere? And then you really start looking at this, you begin to see some of these things uh, that people are concerned about today. What's going to happen with these rising temperatures? What's going to happen with the rising CO2? What's all the variability of rainfall going to do for an agricultural system? So, I've been very blessed over time in terms of being able to carve out a research program that really looked at the dynamics of agriculture. And in the last 10 years, really developed a concept that we call genetics by environment by management, uh, G by E by M. And it's a departure, obviously, from the old classic genetics by environment that breeders use, because the dynamics in that is that we're very interested in what is happening with the management aspects and how are they overcoming the environmental variation that's out there, whether it be soil or weather, and then how do you use that to optimize the genetics. And so producers look at this and say, well, that's what we do in farming. Yes, that is what you do in farming, but now we're trying to get quantitative tools to say, where's the best genetics fit into this, and then what is that real role of environmental variation. So if we have dry periods or we have wet periods, what's going to happen to our agricultural system and all of this. So, it's just really a kind of a fascinating area, looking at how do we bring these pieces together. But it goes back to this aspect of saying the producer ultimately is making the management decisions. There are things that they can control, but there are things that they can't control. And so, how do you really look at that optimization of a pretty interesting biological system that, we all think that we can achieve 300 bushel corn continuously. And everything else, we find out there are parts of the field that don't respond that way. And so that's really kind of been how do we develop a framework that really draws the best of our scientific information together, and then even spit it out at the other end and saying we're not only interested in yield, but we're also interested in the quality of that product as well. And so there's some fascinating pieces in all of this that go along, and they're all interrelated, and we need to start thinking differently about agriculture in terms of the system dynamics, because it is the interactions that are going on. I'll be quite honest, is that as scientists, we're not very good at interactions. We like main effects. What's the effect of nitrogen, or what's the effect of phosphorus, or what's the effect of a new hybrid on this. But when you say, what's the effect of the increasing temperature during August on different genetic material and with extremes in water and nitrogen management, we go, we kind of get glassy eyed at that point because we don't understand all those different nuances that are happening.
Yeah, it's hard to extrapolate all that with the statistics and having a clean hypothesis. So I really appreciate your holistic thinking. I think a lot of that's missing, and we've become very silo oriented in research. So I think you make a lot of people stretch their imaginations on what they should be looking at. One of those things that really stood out to me, and this is, I'm this has been a while ago, Jerry. So you're going to have to correct all the mistakes I make here. But I remember you were doing a series of studies. I think it was 8 or 9 locations across Iowa, where you're comparing no-till, conventional till, and I think strip till. And then later on, you added a hog manure portion to that. And then later on top of that, you started adding carbon sensors within the canopy. And this is what really stood out to me. You're trying to better understand carbon flux and,
Hmm.
and how overnight carbon dioxide levels right near the soil surface, because you had these sensors at, I believe, 6, 12, 24 inches and at 6 feet
Oh yeah.
above the canopy or 8 feet. And you enjoyed all the hard work it took to put those out there. But boilerplate, what I remember, or boiling it down to what I remember, is right before sun up, the carbon dioxide levels at near the soil surface were 2x of the atmosphere, and then within 2 hours of sun up, carbon dioxide levels were equal to atmosphere, and about 4 hours after sunup, they were half of the atmosphere. So you were trying to document that huge carbon swing within a canopy, and that I think's been really kind of foundational understanding of how plants work, right, and how their forage quality is optimized, and why you want to wait to cut maybe forages before 10 hours after sunup, or excuse me, 4 hours after sunup, and those kind of things. Share some of that early work that you did and how that kind of laid that foundation of that understanding between those different systems and the carbon flux and those kind of things.
Yeah, I mean, if you look at this, probably if I had known what I know now in designing that experiment, I would have probably designed it a little bit differently. But you know, you just launch in and you do things, and what we because it's the dynamics of carbon. I mean, you think about people always ask me, how does carbon get into the soil? Well, carbon doesn't get into the soil magically. It requires a plant to extract it from the atmosphere. And what we were trying to do in a lot of those experiments is saying, what are the real dynamics of what's going on out here? And when you start looking at not only profiles of CO2 within within a plant canopy, and then we actually did profiles of water vapor within that canopy as well. And it really kind of went back to my PhD work was actually on how light was intercepted by a corn canopy as it filters down through there and what changed. So, now we're looking at photosynthetic processes going on. But you're right. What we discovered was that in a really dense corn canopy, anytime you get above a leaf area index of 4, which is about halfway through the vegetative period, is that canopy is pretty dense. There's a lot of things happening in there. It's very efficient at absorbing light. And it's very efficient at absorbing CO2. And so people always thought that, well, if this plant's respiring at night, we're just losing all that CO2 back to the atmosphere. And what we discovered is that, because now you had one other piece of the puzzle, is that not only is it respiring at night, but that within that canopy is a pretty calm environment. There's not a lot of wind that gets in there. So anything that moves out, unless it's a really windy night, it stays right there. And because the major question that people were asking is saying, well, if we improve soil, we improve the carbon content of soil, and we increase the respiration rate coming out of the soil, all we're going to do is add CO2 back to the atmosphere.
Right.
Well, a good corn canopy never lets CO2 go to waste. Let's put it this way.
Or any canopy, right? Anything
Oh
in
yeah,
nature doesn't let a precious resource go to waste.
CO2, plants love CO2. I mean, we talk about this rising CO2 levels, and plants say, bring it on. We're happy, And so, they're,
Bring another
we
keg to the college party, come on.
yeah, it's about what it is. It's let's yeah. We thought we were having a 1 kegger, and now we got a 2 kegger, and so life's really good. You know? And so, but you look at that, and that was part of the reason of that study, saying what are the dynamics that are going on within canopies, and we'd find out that the CO2 levels would get to 1,000 parts per million. That's roughly twice. It's over twice what it is. But as soon as that sun came up, and the sun started shining on those leaves, you could just watch that CO2 disappear from the top to the bottom of that canopy. And then all of a sudden it got down to about 290, 280 parts per million, which is kind of the equilibrium point on C4 plants. I mean, it was amazing to just watch that go back and forth. But the other piece that we discovered, which is really pretty interesting, is that when we were observing those CO2 levels, the really hot nights that we were having were increasing that CO2 level even more. And so if you take and start looking at a total budget of carbon dioxide between daytime hours and nighttime hours, is that when you get these really warm conditions, we weren't very efficient in filling grain, because all we were doing was respiring that carbon back into CO2 that was in the canopy, and the plant would take it up the next day. Um, you say, well, it didn't go to waste, but yes, it didn't go to waste, but it didn't add to grain filling. And so, when you see those really small kernels, uh, it's a result of the fact that we have these hot nighttime conditions that basically increase respiration rates, and we verified in that in growth chambers as well. So I mean, it's so you look at the influences on corn and soybean production. When we started doing some very detailed analysis across the Midwest, is that yields were determined by July maximum temperatures. So we get these really high maximum temperatures in July. We disrupt pollination, and you couple that with water stress, you reduce yield. August minimum temperatures. And that's basically just what we were talking about. It is respire, so it's not as efficient in filling grain. And then obviously July, August rainfall. We've got to have rainfall in July and August to make grain. And so you look at all this thing. And so now you've got this combination of effects of CO2 and water and temperature all going on within this plant canopy. And then we're seeing, there are hybrid differences in how they respond and all of this. So it gives us an understanding of saying, let's start looking at this system from an entirely different perspective. And how do we manage it? Why aren't plants more efficient? Why can't we always get to that 600 bushel of genetic potential out there? Well, there are a lot of things that happen, and understanding that gives us some ways in which we ought to be approaching this problem.
And really, I think that early on research, the timing of that again was impeccable, because about the same time a lot of funding came into the ag research community, all with the keyword of climate change.
Yeah.
And I think that carbon being, I think it was outstanding how you and the teams that you interacted with really coordinated to utilize this research for carbon, not only to benefit the environment and climate change, but also to benefit our understandings of growing crops and how carbon cycles within the whole, which we really still don't fully understand. But uh, talk to us a little bit about, okay, so now you've done the atmospheric and this plant interaction, water vapor, temperatures, and all that. That's all part of a climate change model too, right?
Right.
But farmers are getting useful information out of this at the same time. So I think it's amazing how you wove those together, not a us versus them, but how can this be a system benefit for both the climate and the farmer? But then you start looking into soil dynamics, and I know you've been involved in myriads of projects of how to sequester carbon, biochar, and all those things. So what was the next step when you kind of dove into how soil carbon flux happens? And
Yeah, it's soil carbon flux, obviously, going back, I mean, it requires a plant. I mean, we're taking CO2 out of the atmosphere. We're creating a very simple sugar. That's the first step in photosynthesis. Part of that fascinating things we've been working on lately is, really what happens in that CO2 that's taken out from the atmosphere, goes down into that leaf. Some of it gets transported into the root. Uh, there's some fascinating pieces of literature now that are coming out saying that a lot of those sugars that are exuded by roots are feeding the microbial systems. And, it's that relationship. Now we'll add one more complexity. Not only do we have a plant, we have soil, now we got the microbial system in here, that's doing all sorts of things. And, those you've got fungi and bacteria all working together around that root. And so, what's going on in this system
Mhm.
that ultimately is driven by what plants out there? And you think about the dynamics of this. So we have a plant. We grow that plant. We add a little bit more carbon into that soil. We improve the biological activity of that soil. And then next year we can grow a little better plant because we've improved the soil. And so now we put more sugar in there. We have more biological activity. We improve the soil even more. And so the uh, the dynamics of this, in terms of how do they influence things that now begin to change microbial activity, obviously. And then you think about what that microbial activity does. It stabilizes aggregates. It increases the infiltration and water storage capacity. It cycles nutrients and all of this. And we see this throughout the whole plant growing season. So, what is really leading us to is the fact that we cannot come into an agricultural system and say, let's look at tasseling in corn and say, this is what's going on. We've got to look from the time that seed goes in the ground until it's harvested at the end to understand just the complexity of these interactions that are going on. One of the things that we discovered in all of this is just how fragile this system is. Because if you take a corn soybean system and you till that, they deep rip in the fall and then maybe field cultivate in the spring. Uh, you know, you we find that we're losing 1,000 pounds of carbon per acre per year. And so, that's you go, well, that's only half a ton. We got 2 million pounds of soil in that plow layer out there. So, that's not bad. But if you farm 20 years or 40 years, you've lost 20 tons of carbon. And we see this across the Midwest. I mean, we continue to see degradation of organic matter contents. Uh, but, as we begin to decrease our tillage intensity, add crops that add more carbon back into that soil, uh, then you begin to see this rapid change in carbon. And everybody wants to say, well, we can just look at soil organic matter. Well, that's only one piece of the puzzle, because you've got stable carbon, you've got all these unstable pieces of the carbon puzzle out there.
What
You
kind of
got
carbon is it, correct?
Yeah.
Is it
Yeah,
a simple
you know
sugar or
it,
is it humus? And there's a
well you
whole
know
range in between, you know?
yeah, it's this whole continuum of carbon across there. And so you got bug bodies that are out there. I mean, a lot of those are storing carbon is in their cellular structure and everything else. And it doesn't make it into organic matter, but it's carbon that's in that soil. And and they're having all sorts of positive values from that standpoint.
Mhm.
So now we've just become more complex in terms of this. But I think we've now gone to the level of saying we think about the complexity, but now we understand why we have the complexity that we do. Uh, and you start looking at this and saying, let's add uh, organic matter back into that. You mentioned biochar as an additive in there. Well, one of the things that biochar does is that it improves the physical structure of that soil, but it also is a great hotel for the microbes. There's a lot of intercellular spaces that microbes can glom onto, or fungi can glom onto, that these got water and nutrients kind of in those little spaces. So I think we need to think differently about even what we put in there and what we do with all that.
Right. And yeah, not all carbon is the same is the key point there. And I found it interesting while you said it's fragile. what carbon in the soil is with a tillage event. But also earlier before that, you're saying that we can make this continuous improvement in soil
Mhm.
quality quickly. So what I think is when you're dealing with soil that's considered to be old, but it's amazing how rapidly we can improve or how rapidly we can degrade soil, and it's sometimes a matter of just one simple decision
Right.
that can make a dramatic difference. And my personal least favorite tool is the high speed disc mock till, turbo till, these kind of things.
Yep.
First off, they're a lot of fun to drive, right? Because you're going fast and you got big horsepower. So I mean, for a farmer, it's a Tim Allen, kind of moment to do it, right? But that one simple decision to do that really can change everything from what you're talking about there. You
Yeah.
might have the residues incorporating, but what was there from the past, either simple saccharides and microbial food, that's all been oxidized. So
Yeah. In fact,
huge.
we ran another experiment in which, based on our observation that the conventional systems were losing those 1,000 pounds of carbon, so we took another field, same instrumentation, with the fluxes and everything else, and we changed it over to a no-till cover crop system. And when after the first year, we went from a negative carbon balance to a positive carbon balance. Uh, we were accruing about 300 pounds of carbon in that first year, which is it's pretty remarkable change in that. But at the end of the second year, when we went back and did some very detailed sampling, we had doubled the microbial biomass in that upper 6 inches across those fields. And so we were putting a lot into that biological activity, putting a lot into that system and all of this. So, things occur quickly. And so I get very frustrated with people say, well, take decades to change organic matter. Yeah, it may take decades to change organic matter with the way in which we sample it. But I can tell you that things respond within a growing season. In fact, we've seen aggregates begin to change within 140 days of, of manipulating a system, in a growth chamber and everything else. So, I mean, there is Mother Nature is going to respond quickly to what we do to it, both in a positive and a negative direction. So, we just got to figure out what direction to maybe push it at times.
We're taking a short break to share that the AgEmerge podcast is brought to you by the team at Ag Solutions Network. Rooted in innovation, ASN is committed to leaving the land better than we found it, not simply maintaining it. We're here to help you navigate the balancing act of productivity and building a legacy. From practices to products, ASN is more than a new jug. It's a new way of thinking. So don't be afraid to be different. Be afraid to be the same. Contact Ag Solutions Network today at asn.farm. And now, back to our show.
The takeaway from that is there's hope, right? There's hope that we can regenerate soils and we can do it quickly if we do the right practice by your G by E by M. So that's kind of
Right.
the capstone there of looking at how we manage it. We can make changes in resiliency quickly. It's just, can we make changes between this 6 inches between our ears, this really heavy, really high bulk density in this gray matter up here, Jerry. So
Yeah, yeah. The highest bulk density may be the 6 inches between the ears, but you look at all this, and I think that that's what I get very frustrated with the discussion about carbon markets, is because we talk about the value of carbon markets in terms of reducing CO2, and ag is a great sequester of carbon and everything else, and saving the planet. And all of those things are good, but my pitch is to the producers is, what's the real value of carbon to you? What does that carbon mean for your system? I'll just give you an example of some work that we've done with Wayne Fredericks up in northern Iowa. Um, Wayne gave us a set of data from 2000 to 2000. Well, actually, we got it through 21 now, but Wayne and I got very curious of what was changing within the systems as he went to reduce tillage, and then he started adding cover crops. But what we did with his data, this is data across 10 fields, so it's not just a single field, it's 10 fields. And we took the yield monitor data within those 10 fields and we sliced it by the soil type within the field. And so we put a mask on it. Uh, and because what we began to discover is that as we were improving organic matter through reducing tillage intensity, is that those the yields within each of those soil types was becoming more uniform. Uh, and you start looking at that, they're becoming more uniform. They were becoming more water use efficient. They were becoming more nutrient use efficient because he hadn't changed his nitrogen application and yet was producing a lot more crop and producing a lot more crop per um, inch of rainfall during the growing season. So you start looking at that, and I've talked to more and more producers about this, saying, "What have you observed in your fields?" Not going to the intensity in which we did Wayne's analysis. And they said, "Well, our fields are becoming more uniform." Uh, and you look at that, so that's the value of this because you get those low yielding parts out. That's profit. Uh, and so there's a value of carbon that is way beyond the $10 or $20 a ton that we talk about for the carbon markets. Now we're talking, 100 to $200 return across parts of those fields. So getting producers to understand why do they have the variation that they have, and what's their management plan to be able to overcome that variation, and what do you observe from year to year in terms of the changes that are out there.
And I think that's, even if we're focused on carbon for a carbon contract, maybe that's the wrong primary reason. The good part is that all of the benefits to the farmer are going to align. So like you said, increased water infiltration, holding capacity, better nutrient cycling, more consistent yields. We see that consistently. So that's those are all great things. So I know a lot of your activity involved with the tri societies, soil science and crop science and agronomy society of Americas. Um, you were quite the cat herder uh, in those things. So talk to what it's like to go with coordinated efforts to accomplish research across multiple sites and multiple researchers aiming at the climate change type of initiative things that you've done. What that's like to get meaningful research done that can impact a farmer.
Yeah, I mean, that's I think you start getting that question in terms of meaningful research that impacts a producer. The first critical step in that is involving the producer. Uh, Too often in a lot of our research, and producers will tell you this, that they don't trust small plot research because it doesn't they can never identify with a 4 row by or 6 row by 50-foot plot out there and say, what does that represent? Um, I remember when we did a study across, and you mentioned it earlier, a study across Iowa where we were comparing no-till, strip-till, moldboard plow, and chisel plow across multiple sites in Iowa. When we first went to the producers and said, we want to run this study, we want to look at this, and the producers said, you were interested in this, but there's always a but we want to see these comparisons across fields. We don't want to see them in a nice little replicated plot at the end of the field. So we ran those strips across um, soils within the field, up and down landscapes. I mean, because we were in southeast and northeast or northwest Iowa and everything. So we got all these, and I think that was that was instructive in saying they want to see how these things respond in the fields in which they're operating, and they want to see how it's benefiting or not benefiting what they're doing as well. And so I think if we want to get research translated into uh, practice, is that we have to involve the producer as part of conducting that research. And that always doesn't, people get heartburn across that because, well, what do you have for a true statistical test? What do you have for, a nice replicated experiment out there? Well, I mean, we have statistical techniques that allow us to look at field scale that are way beyond the old classic randomized complete block design anymore. I mean, we can draw inferences out of data sets. It's a matter of getting the question out there, getting the players involved, and collecting the correct information as we go along. But that's the first step. Is if we want to impact the producer, is the producer's got to be part of the solution and part of the questioning.
Yeah, and I agree, and especially when you're looking at systems instead of just isolated one product and such. And if there could be more of a way for uh, scientists to come alongside producers and quantify what they're doing, I think that can make, like you said, more lasting changes and a better understanding of what's happening in a system. So hopefully that continues to happen.
Well, I think it will. I think that producers are becoming, a lot of producers have become their own experimentalist. They try all sorts of different things in their fields. uh, I think we can work with them in terms of, are the validity of those results. Going back to the discussion about continuous improvement and adaptive management, they're trying different techniques. Well, how does it work within a field? uh, and did it work? I always use this as an acid test of how the producers thought about some of the things that we wanted to do. Is that if a producer said, that's a good idea, but we're going to put it on this field that's farthest from the road, I felt that they didn't have a lot of confidence that this was going to work. But if they felt that this was a pretty interesting system, they'd put it out next to the road. And so I always use that distance test from the neighbors
Is
as a
that
way
one
of
of the variables that you put into the statistics is
yeah.
distance from a hard road?
Yeah, distance from the hard road. And we talked about the CO2 pieces and some of the other ones. Is that you know people always ask where I got some of the wild and crazy ideas that we've done over time, and part of that is come from producers saying, you know, we need to understand how this works. And so a lot of it is a pretty interesting dialogue saying, yeah, we don't understand this, and what's going on with interactions of nitrogen and water. How do we look at all of this, and how do we look at this system differently? And so if we add that cover crop, what's it doing? And so a lot of those crazy things that we've done over time are, yeah, just lay at the foot of the producers that planted a seed and saying, we don't understand this, and you got to help us.
Right. And you've done that by being in the field too,
Oh yeah.
getting out there to see it. And I think that's one of the keys to the immense amount of work that you've accomplished over time is being in the field. And I think too often um, others can send too many grad students and such to go do the work, versus you've cast your shadow in a lot of fields, Jerry.
Well, yeah, I was a very poor administrator, probably in terms of direction. I love to interact with the producers, and that's what's been so enjoyable about the last 2.5 years. Is that I do interact with lots of different producers, and we have some pretty interesting discussions going on.
But not too early in the morning and not in the afternoons. See,
That's correct. Yeah, well, I
you got
do
to
have
catch Jerry between 9 and noon. So
9 and 2. Yeah, that's a true banker.
there you
But
go.
And so you look at this. Um, I think that ag has challenges. I mean, how do we really feed the world of the future? Uh, and I think that that's a phrase that often gets thrown out there, and uh, you got two camps. One is that you're either an optimist or a pessimist in that statement, and that we're all going to die of starvation, or that ag will overcome it. And I actually believe that ag can overcome this, but we're going to have to start thinking differently about how do we get the most out of every acre of soil? How do we get the most out of every hybrid or variety that we put out there? How do we get the most out of every product
Mhm.
that
Sure.
we apply out there? And so it's not a matter of saying there is a silver bullet. It's a matter of saying we've got to look at this from a systems dynamics and really bring in some pretty inquisitive questioning, in terms of saying, why don't these things work? Or, I think a lot of times that we often put things in the camp of saying, well, I tried this and it didn't work. And the other person tries that and it works. Well, what do we learn from our failure? What do we learn from our successes? And so you talked about what we were doing in the tri societies, because um, I continue to do all sorts of interesting things. But one of the journals that we started about 5 years ago is Agrosystems, Geosciences, and Environment. But the unique part of that journal is that we will publish negative results. Uh, and we'll publish short-term experiments. So if you've got an experiment that failed, but we think is really high quality science, we'll still publish it there, because I think a lot of times we repeat the same thing because people
Didn't know
never
that it
understand.
yeah, you
It
didn't
never
know it
was out
failed
there.
for somebody else, right?
Yeah, yeah.
And, oh, that is awesome because there's so much that is not published, like you said, in the failures. They only publish the success.
Well, and it's also the place in which we can put a lot of the on-farm experimentation pieces out there. Um, and all of this, so that we can begin to draw this information together, uh, and help consultants, help scientists, or help consultants and industry people interpret these for the producer as well. So, I don't think there's any such thing as a failure. I think it's just uh, as one farmer says, there's really not a failure. It's just a result I didn't expect. Well, you know, sometimes they do fail, but why do they fail, and what can we learn from that? So every day is a learning experience.
Absolutely, absolutely, and I learn a lot from failures. Um,
Mhm.
not only not what to do, but also what I should have done, and I think those are all key things. So early on, before we started recording, you mentioned there was some technologies, emerging technologies that you're pretty excited about that are going to be part of this system, and you didn't share anything about it, so it's a surprise to me too. So go ahead and share some of these things that you're looking into and have run across that you think offer some great hope for the future in agriculture.
Well, I think that part of this, and I'll kind of break it into uh, two different categories. The first category is observational technologies. I mean, I've been involved in remote sensing since the early '70s, when Landsat was up there, and things like this. And we always ooh and all over the pictures that we can make with satellites and things like this. But I think we're now getting to the point of how can we take that information and really help producers build that library of what's happening across their fields. And so we're looking on some technologies of how can we really uh, build a system that monitors that field and allows us to look at it not only this year but last year, what's changed from year to year in this and all of this. And so I think that that's one of the technologies that we're looking at right now, is how do we utilize that. The other one is the observational techniques of how do we really sample soils. I mean, you really get into this, and I mean, you know, are you in the 2.5 acre grid, or are you in the random uh, soil sampling, or are you in the 1 acre grid? I mean, how, and all of this, they all have pluses and minuses. Um, but how do we really sample that? I think one of the frustrations everybody has in the carbon market is that we're trying to look at the whole profile of the soil, that 5 foot profile, but we're only sampling the other 6 to 12 inches and saying, well, what's going on underneath? And so how do we build some other technologies that allows us to sample that? Can we analyze that soil in the field so that we're not carting everything back to the lab, and how do we utilize those technologies? And then the other piece is really kind of the technology piece, is how can we use things like machine learning and artificial intelligence. I mean, you start looking at all the information that's flowing in from a producer or from a tractor now. I mean, you look at all the information flow, is how can you use that to say, this is what happened in this part of the field. Now, with all the spatial technologies that we have, bring it together and say, yeah, we can. Now we understand why this part of the field didn't respond the way it did. And so it's an integration of information that kind of puts us beyond uh, our capabilities. Uh, and not that we should fully trust computers to make decisions for us, but they can amass information and crunch numbers in ways in which we can look at that and say, this is kind of what's going on. But they're going to develop some relationships and looking at some of the system dynamics that we don't have the mental capacity. Not only are we pretty dense between these ears, but we often think in preconceived relationships,
Exactly.
uh, and I think we've got to get past some of our preconceived ideas.
That's what I'm most excited about on AI, is that there's no emotions and there's no hurt feelings. So understanding that maybe something you thought to be true before, all of a sudden the data set's saying it isn't. That's an awful hard pill to swallow. And plus the immense amount of information, especially what you're talking about with systems-based
Right.
research, when we've got so many inputs and then so many variabilities within year and year to year. Having the ability to quantitatively compute that is wonderful. If we can get machine learning or AI to tackle those things, and we're close, aren't we?
Oh yeah, I mean, we're very close. I mean, we've put some of the AI through different pieces, and because one of the dynamics was saying, how could we really detect when tasseling has occurred on corn? Switch from that vegetative to the reproductive stage. Well, I mean, we've played around with all sorts of different indices, but we just fed the data into the computer and through all that, and it came up with some different relationships and wavelengths in terms of some of the remote sensing that we hadn't even tried before.
Hmm.
And, they're pretty stable over time. Uh, and so you look at all this and saying, yeah, let's get some of the emotion out. Computers are, well, I don't know. There are days I think they have emotions because they like to frustrate us, but you look at all this and saying, let's take an entirely different view of the system and how things are interacting that we didn't consider before, because we go into every problem in agriculture, and we come in with our preconceived biases. Well, is it if it's a failure out there, obviously it's a hybrid problem. Or if we put a different product into that system. Obviously, it's a failure of that product. Well, it could have been a simple thing like it didn't rain. in a 2 week period that we saw some of the things occur out there. And so we and the computer just emotionalist takes and begins to say, you dummy, if you realize that it didn't rain for 2 weeks and that's why it didn't respond the way it did.
Exactly. Well, the best part is once we can get that to where we better understand what the interactions are, now then we can create a yield prediction model, which has
Hmm.
kind of been the holy grail. And I remember doing a project on that in college, and we're still not there yet. But we can get to some yield prediction model, or we can run some what ifs ahead of time. So I can have this field, and I say, okay, I want this hybrid with what would basically uh, we'll have to have the Ellen Taylor module attached to it. What the weather's going to be next year. Uh, you know, those kind of predicted and get really a distribution curve of what the predicted outcome would be, and definitely will build in more resilience uh, for a farmer in revenues, and you can also then use those things to hit certain goals. Maybe you have certain crop rotations or crop selections are better at improving carbon sequestration than others, and that can be built into that model. And you can look at not just what I'm going to plant next year, but here is what I'm going to plant over the next 10 years. And instead of 2 crops, it can be 9 crops. And we can see what all those interactions are with each other, which is a real headache when you're doing it now with an Excel spreadsheet, right?
Yeah, Excel isn't very good on spatial dynamics.
No. You got you
And
got you
and
got me banging a keyboard on an Excel spreadsheet, so I say, that's about as bad as it can be, right?
well, you got I think agriculture is the ultimate spatial temporal
Yeah.
problem out there, and I think the more that we can get technologies to look at this, but
But really
the
looking at those future choices,
oh
I
yeah,
think that's what I'm getting at, is I'm trying
yep.
to best guess where am I going to be in crop rotation for the next 5 years, and that's it. Yeah, it's a wag.
Well, it is a wag, and I look at this and saying, but let's look at this, and I think that it feeds nicely into this dynamic of the adaptive management. So let's set up our 5-year plan.
Hmm.
But as we look at the end of the first year
And
and we say, well, this didn't quite work, it didn't quite give me the response, what went on, and then you make that tweak, and then you look at it the next year, so it's a continuous improvement process,
mhm.
uh, and looking at the spatial dynamics within the field, or the temporal changes out there. In a lot of cases, um, going back to the example, is that we often tend to blame lack of response on the one management piece that we did. So we put a product on, or we switched fertilizer application timing. And so, well, obviously that didn't work, and you find out that in the grand scheme of things, it had nothing to do with that. It was the fact that it didn't rain for that 2 week period. Uh, that was critical to grain development, and I think that uh, I always tell producers that if we really look at the dynamics of crops, let's go back and start looking at the yield components. I mean, let's look at going back to corn. Ear size, which is set really early. Number of kernels, which is set, during the pollination phase, and then size of that kernel, which is really determined with the grain filling period. Well, all of those add up to what we get in yield, but they occur at different parts of the season. And so it's not a one-time thing. Even soybeans are not a one-time thing. And wheat is not either. And so you look at all our different crops that we grow, getting much more analytical about how that yield got there, and what caused that different response out there. I think will give us new insights of how we need to be looking at this system. So some of the technologies we're looking at are basically that continuous yield progression monitor, and saying let's look at what's going on, and let's look at the efficacy of that plant in terms of not only capturing carbon but utilizing water and nutrients efficiently.
Yeah. Yeah. And I think that tools will get better and better for that to be able to make unbiased decisions. And that's pretty exciting. And really, it's all about, like were alluding to earlier, we need to think of farming in a Six Sigma kind of way,
Yep.
continuous improvement and those kind of things. So I think farmers do that. They just don't know they're doing it. And I think
Right.
we need to be more intentional about that. So, okay, big picture here. You've been retired 2.5 years. You're having your coffee with your wife until your banker's hours, and playing golf probably in the afternoon, and causing chaos and giving ideas for other people to have to do now. So that's great. That's all part of it. But what do you think, looking back on your career thus far, or when you what do you think's been the biggest uh, or one of your most proud contributions that you've made?
Looking back, I think some of the most the proud contributions is being able to say, I've helped agriculture, uh, and it's not a single, not a single producer, not a single commodity, but basically said, this information helps agriculture become more resilient. It helped agriculture become more efficient, and being able to explain that to producers and saying, here's a path forward uh, in all of this, so that they can come in and say, I was able to take that information and utilize it and put it into practice. And you know it's a dialogue. I mean, a lot of this is, I've discovered that nothing with a producer is a one and done thing. It's a basically, and it goes back to what we were talking about earlier, is the transformational agronomy. To me, the transformational agronomy is, if we want to transform agriculture, it's about a relationship. uh, and that proud moment that I have is basically saying, I was able to impact the agriculture as we have today and where we're going in the future, and I've continued to work in that whole vein and everything. That's what gets me up in the morning, keeps me excited about where we're going.
Well, I so appreciate all that you've done and all that you've contributed and all the leadership you provided to farmers, but also to other researchers, and pointing everyone in the direction that we need to be thinking and heading toward. I think that is critical to the impact that you've made. And I've always enjoyed our discussions whenever we have a chance to bump into each other at various meetings. And um, you're you're fun to interact with, and people need to get to know you if they don't. And it's amazing, all the prolific work that you and your teams have done. It really
Well,
is.
thank you.
I'm very appreciative. And the only last thing I got to ask is, when are you running for president? I mean, I really think the way you can navigate Washington and all these diverse groups, I'm thinking 2028 or something, whatever the year is, Jerry.
I'm way too old at that
I'm
point,
voting
Monty.
for you.
But I think you look forward and saying, I can have a real impact on agriculture where I am today. And and groups like you know the big soil health event. We got another one coming up in December again. We got another offshoot of a meeting at the end of that week in Kansas, that they're trying to get people together on to start having a discussion with producers about where they at, where can they go, what are some of the technologies, and what are some of the questions they need to be asking.
And I think you said something really key there. Asking everyone listening to this needs to ask themselves, what kind of an impact can I have on agriculture? And
Right.
you can, right?
Oh yeah.
And if you need help, Jerry will get out his jackhammer and work on the bulk density between the ears, right? You're
Yep.
always happy to do that and reach out to you. Anything else we should have brought up in our time together today, Jerry?
No, I think that's pretty good. We have to have another conversation sometime along in all of this. But I'm optimistic about the future of agriculture.
Mhm.
I think that we've got a lot of capabilities. We've got some, our future world depends on us. But I think that we've got to come in and say, we've tried some things in the past. What can we do differently? And what can value can they add to us? Because I always talk to different groups saying, what value are you really adding to the producer? And I think that's the way we need to be looking at this right now is saying, let's look at everything from a value add proposition and saying, are you adding value to that producer's system? Are you adding value to that producer's well-being? That psychology and the sociology of the producer as well.
Yep. Great questions to always ask. So thank you so much for your time today. I really appreciate it. It's good to connect again. And I wish you continued success and impact in everything that you're doing.
Well, thank you. It's
All
been
right.
a pleasure.
Take care.
What a great conversation. While Jerry's bio says retired, he is far from retiring his involvement in helping growers change and challenge their ideas and thoughts as he helps them continue to pursue systems that can increase their production efficiency, increase soil health, and develop resiliency. And as always, if you'd like to learn more about what we're doing to help growers implement soil health, check out our website at asn.farm, and there you can click on links to follow us on Facebook, Twitter, Instagram, LinkedIn, and YouTube. There's a lot of great things happening and always something to learn. Thanks for listening.